This is Dr. Troutman coming to you with another article Wednesday or Friday or whatever day of the week that you're watching this. Today, I'm representing Clemson University for our article. I'm actually going to highlight the research done recently by my PhD thesis advisor and a person I really admire and look up to, and that's Dr. Sean Britton at Clemson. So let's dive in so that we can jump in, keep this as short as I see how long I'm going to talk for today. I'll try and keep it shorter. All right, so we are highlighting some research from Dr. Britton. So again, I am grabbing, just as if people are curious, I'm grabbing these articles from a site called arXiv, and it's arxiv.org. This is a place where researchers will put their articles up so people can get access to them, and it's easy to really grab pretty much any kind of article. These are generally things that are either submitted to be printed or are on the way to be peer reviewed. So today we are looking at high resolution near infrared spectroscopy of HD 100-546. Part 4, Orbiting Companion Disappears on Schedule. Ominous title from Dr. Britton. So let me simplify our title here. High resolution near infrared spectroscopy is an observation. So this can just be an observation of HD 100-546. If you remember back to the last video, we talked about astronomers not being very clever with their naming. So this is a star that is observed in a catalog, the HD catalog, and it is the 100,546th star in that catalog. This part 4 refers to this paper is a 4-part series. This is the 4th paper that comes out about this star from Dr. Britton. And we are going to observe an orbiting companion. So this could be an orbiting companion, can either be a star or it could be a planet. More on this in a minute. And then disappears on schedule. So that is what we're going to talk about today. To understand this more, we do have to talk about planet and object formation. For this purpose, I'm just going to talk about planet formation. That is how we form planets and what that means for this system in particular. So we start our story with a cloud of gas plus dust. It's not gas and dust, it's gas and dust. So just as a heads up there, gas and dust. So this material, gas and dust, will be in a cloud, and something shocks it, something perturbs it, moves it, and then gravitational forces come into play and collapse this gas and dust down over time into some central star and a disk that is orbiting around it. This disk is of material of gas and dust. Right? So we have a central star and then a bunch of stuff orbiting around it. The central star is still there. The stuff is orbiting around it is just other gas and dust that made up that star in the first place. So I'm going to switch my view and note that this is our view, observer view. That's our symbol for observer. And we're going to look down at this system. So we're going to look down at this system, and I now will have a disk here with a central star. So this material of gas and dust will have a lot of stuff going on inside it. We might have areas where more gas and dust clumps together, and if that happens, we might actually form some sort of planet there. There are a couple of different theories on how this happens, and the good news is there's still more exploration to do on the specifics of how you get from a single gas and dust grain or molecule all the way up to something that's like a Jupiter. How do you do that? Well, it's a really good question, and there's a lot of research that is still yet to be done. But we'll do the hand wavy thing and say that we have formed a planet, and it is orbiting around this central star. And what happens is this material wants to move in from the outer regions of this gas and dust cloud, or disk around it and move in towards the central star. Why does that happen? Well, the gas and dust that's orbiting around the star is going to interact with each other. That's friction. There's an effective friction there. And what it's going to do is that material is going to lose momentum and want to spiral inward towards the central star as it loses momentum. Well, that would happen unless you have some sort of big object like a planet or another object in the system that is shepherding this material and keeping all that material away. The same thing actually happens in Saturn. In the rings, if you look at the bands that are between the rings, we actually see shepherding moons. That's what they're called, shepherding moons, that are carving out that small little band in between the rings. Well, the same thing happens in a system if we have a planet or another object forming, is that all of this material will want to move inward, right? Spiral inward as it wants to come in towards that central star, but then it's going to be blocked, shielded by this other object as it moves around. Anything that's within that shielded region is still going to fall in towards the star. So what you get is this gap where there's no gas and dust in this region that I'm shading in pink here. No gas and dust except for the planet or the object that's orbiting and the central star. So why is that important? Well, observations were done a long time ago, back in 2003, of this system, and there was just the central star there, and then what we are looking at, central star is here, and then the gas and dust that's all around it. So back in 2003, that seemed like a normal observation. Actually, in 2006, there was an observation of something extra, some other thing that is in this system, some companion that is in the system. Went back, so the way that this actually worked in reality was 2006 was the first observation, noticing that there were previous observations that were done, looked backwards and found there was nothing there. And then in 2010, there was that evidence for that companion, that other object in the system that has moved. And so that was done way back when in just after that was 2018 or so. And some little known researcher at some institution locally was part of this research, at least in part. Dr. Britton and colleagues that are above that other researcher did a lot more of the heavy lifting here. So what happened? This was the previous observation. So back to our original story, the disappearing companion. Well, the orbiting objects, if you remember, back in 2003, there was no observation. In 2006, there was an observation. 2010, well, if the orbit of the object continues, eventually, it is predicted that, let me go back to this object. So eventually we follow this orbit, it's gonna go and hide behind this wall. That object that's orbiting around in this system will be shielded by the gas and dust that would be blocking from our point of view. And so that's the prediction that was made, is that in 2017, there would be no observation. So we did look and see in 2013, it's there. And then in 2017, the planet, I shouldn't say the planet, the orbiting companion was gone. Okay, so that's really important and helps us identify what is going on here. I'm going back to the original slide with the title. So the observation of this star showed that the orbiting companion disappears on schedule. So disappeared as expected. So what does this mean? I'm gonna stop sharing here. And why are we being a little cagey or unclear about whether it's a star or a planet? Well, as good as these observations are, they cannot unfortunately tell us the mass of that orbiting companion. The precision isn't there, and other observations that have been done aren't detailed, aren't to the point where we could say for sure what the orbiting mass of the other object is. And so that's really important to note, that while there's a lot of information and cool things that have been researched with this, there was a hypothesis that was tested, and it was confirmed or supported, that hypothesis was supported, that the orbiting companion would disappear. It disappeared. So this leaves a future question to be answered, and that is, what is the mass of that other object? Because if it's something like a Jupiter mass or somewhere around that size, that might be a planet that is forming currently, which is very cool to see that we would be observing a planet in formation. Otherwise, if it's a larger object, it might be a brown dwarf or another star that's orbiting. Either way, what we're seeing is something that's very young. This is a system and a companion there that's very young compared to what we would normally observe in other systems. So that's why this research is really, really important. And as you can tell, it's something that I'm still passionate about. I was very lucky to have great support while we were working on some of this, and I am very happy to say that I played a very small role in doing some of these observations. If you have any questions, as usual, please send me a message, an email, or send me if you have any questions. I'm happy to answer them, and I will talk to you soon.